Hello class, today we're going to chapter 3 on Frame Relay. Okay, Frame Relay is an extremely efficient and flexible wide area technology. Okay, it used to be a most widely used wide area technology in the world until the internet comes in. Okay, because of its low price and it's very flexible. Okay, as organizations grow, they rely and depend a lot on networking, on data communication, okay, especially across wide area network. Okay, when they need to connect one site to another remote site. Okay, and previously lease line is the only option. Okay, and lease line is very expensive. Okay, so now came Frame Relay. Okay, Frame Relay helps to reduce the cost by using less equipment, make it less complex and easy to implement. And in addition, it also provides greater bandwidth, more reliability, and more resilient than traditional lease line. Okay, Frame Relay Cloud basically make up of many frame relay switches. At the edge of the cloud, we have the DCEs. Okay, the DCE basically provide an interface to connect to the DTE, which is a connection to your local area network. Okay, so how does this frame relay switch packet inside the cloud to reach from one DTE to the other DTE? Okay, basically, okay, we have the DTE here. Okay, you try to send the packet out. So when you send out the packet, there will be an address here. Okay, the address will help the DCE, okay, at the edge of the frame relay cloud to switch the packet. Okay, and the different frame relay switch will then, based on the address, okay, and helps to direct the packet to the destination. Okay. Okay, so how do the packet identify the path, okay, to the destination, from the source to the destination? Okay, basically, okay, the path is called the virtual circuit. Okay, it's a connection between the frame relay network between the two DTE. Okay, the circuit are virtual, okay, or the path or the connection are virtual because there's no direct connection from end to end. Okay, there's no direct connection between these two DTE. Okay, in between there are many frame relay switches. Okay, so it's virtual, it's logical, there's no dedicated physical line, and the frame relay is a shared bandwidth among multiple users. Okay, so this frame relay circuit is a shared bandwidth between multiple users. So different DTE or different company uses the same cloud. Okay, and any site can communicate with any other site without using dedicated physical line. So which is why, okay, the cost is cheaper than compared to lease line, shared bandwidth, and no need for dedicated physical line. Okay, there's two types of virtual circuit. One type is called the switch virtual circuit. Okay, these virtual circuit are established dynamically. Okay, so only established when needed. So it's established using a call setup and it's terminated using call termination. So after the call has been set up, you can send data transfer. Okay, you can send data in the data transfer mode. Okay, as compared to permanent virtual circuit, okay, the circuit are pre-configured by the ISP. And once they are set up by the ISP, you will operate only in two modes, data transfer and idle mode. So there's no need for you to do call setup and call termination. So permanent virtual circuit will be faster. Okay, but of course it will be more expensive than a switch virtual circuit. In our module, we'll focus mainly on permanent virtual circuit. How does the ISP, okay, permanently or pre-configure the frame relay switch, okay, to establish this circuit. Okay, let's look at how the packet is being switched. Okay, if you notice a line in red, this is actually the virtual circuit that has been pre-configured by the ISP in a permanent virtual circuit. So when the DTE send a packet, okay, you will follow the path in red. You follow the path, okay, in red, and the packet will then switch from frame relay switch A to B to C to D until it reaches the destination. Okay, so this information on how to switch the packet is stored inside the memory of each switch. They will store the input-output mapping. Okay, there's this number called DLCI. Okay, you notice in this diagram there's this DLCI number. Okay, what is this DLCI number? Okay, this DLCI number helps to identify the virtual circuit that the packet should take. Okay, so let's say if the packet is supposed to travel from here all the way to here, they will use this DNS number 102. So basically, DLCI number is an address. It's a layer 2 address. Okay, so it helps to identify the virtual circuit that a packet should take so that it can reach the destination. Okay, DNS numbers are locally significant. That means beyond this link, you will have this DNS number will have no meaning in other links, which means that this same number 102 can be used on other links. Okay, rather than a global number, which once you use it, other link cannot use. So 102 is only have meaning in this particular link. Once it exits this link, okay, you have no more other meanings. Okay, later I'll show you what does this mean in case you are confused. Okay, so let's look at the DNS number. Okay, when this DTE send a packet out and it's supposed to go to this destination DTE, okay, this virtual circuit is identified by the number 102, okay, in this link. Okay, so this 102 only have meaning within this link. So as a packet is sent to frame, as a packet is sent to frame relay switch A. Okay, let's look at how the packet's been sent. Okay, you notice in A is already pre-programmed by the ISP, saying that if A receives a packet from its port number 0, okay, and the DNS number is 102, okay, he will change the DNS number to 432 and send it out through port 1, which is here. Okay, so now notice the DNS number have changed to 432. That's why this 102 only have meaning in this link. Once it's passed to the frame relay switch, they will change the number. So no more 102 anymore. It's changed to 432. Okay, send out to port 1. Okay, switch B receive it. Okay, so inside switch B is also pre-programmed by the ISP, saying that if I receive a frame relay packet, okay, with DNS number 432 from port 4, I will switch it out to port 1, which is here, and I'll change the DNS number to 119. So notice the number have changed, DNS number have changed. So the packet will continue to move with different mapping, okay, until it reach the destination. Okay, and notice at the destination, the DNS number changed to 201. Okay, and you will forward out to port 0. Okay. Okay, and finally you reach the destination. Okay, so as a frame move across the network, okay, the DNS number change. The frame relay switch will label each virtual circuit with a DNS number, and this is stored in the address field. Okay, so the frame relay, okay, the packet here, okay, there will be a header here, and the header will store the DLCI number, which will be read by all the frame relay switch. Okay, so the service provider will actually assign the DLCI number, so they'll pre-program it. So once you subscribe to the service provider and tell the service provider, I want a connection from this link to this link, okay, then the service provider, the ISP, will then pre-program this table for you so that the packet can travel from the source to the destination. Okay, DNS number from 0 to 15 and 1008 to 1023 are reserved for special purpose. So any number, okay, not within this range, that means between 16 to 1007, the ISP can use it. Okay, the advantage of using DNS number and frame relay is, okay, frame relay is statically multiplex. Okay, you can transmit one frame at a time. Okay, but many logical connections can exist on a single physical link. Okay, which means that the router that's connected to the frame relay, okay, this router can have multiple virtual circuits, okay, going to different destinations. So how do you identify the packet? Let's say from R1 you want to send it to R6. Okay, so if I want to send a packet from R1 to R6, this is the packet. I just insert the header here. I say I want to use DNS 102, and the packet will be able to send to R6. Okay, if I want to send a packet to R2, Okay, so I'll just send this, I'll package this packet with a header and the DNS number say 319. So the frame relay switch is able to send the packet out to R2 using DNS number 319. So which means that I only need one physical connection here, and I can send it to multiple different destinations using DLCI number. Okay, so that's the cost advantage of using multiple virtual circuit. Okay, each endpoint only need one line, one interface, 10000. Okay, and then I can connect to multiple destinations. And also with frame relay, we will pay for the bandwidth that we use. Okay, so in effect, we are only paying for the ports. Okay, so if I increase the number of ports, I just pay for more bandwidth. But I do not need to have more equipments. There's no need for more equipments because ports are virtual. That means the port are identified by the DLCI numbers. So if I have 3 connections, all I need to use is 3 DLS number or 3 virtual ports. Okay, but physically I only need one serial line only, and just using different DLCI number, okay, then I can create 3 different connections to 3 different destinations.